In this video, we're going to talk about pH, which is the measurement of the hydrogen ion concentration in solution, specifically in our body, what we're referring to, because this is a human physiology class. My name is Matt Halter. It's June 17th, 2020, Corona summer, COVID-19. One thing I do want to say about myself, I'm putting out a number of videos for this course. They're all on YouTube. They're all public. I'm okay with that. I want everyone to learn from it, whether you're in my class or not. But one thing I want to highlight, nothing I will say on this video, previous videos, or subsequent videos are original thoughts of mine. All of these things I've learned as a student. I've learned from textbooks. I've learned from professors, colleagues, and I always learn from students. So please keep that in mind. I'm really just a country bumpkin who somehow got a job teaching human physiology. With that said, let's move forward and talk more about pH. Once again, pH is the measurement of the hydrogen ion concentration in the body. And we have a pH scale to talk about this or refer to levels of pH in the body, or specifically levels of the hydrogen ion concentration in the body. The pH scale goes from 0 to 14. And right in the middle is 7, because 7 is right in the middle between 0 and 14. Anything between 0 and 7 is what's known as acidic. Anything from 7 to 14 is known as alkaline or basic. The smaller the number, the greater the hydrogen ion concentration. For example, if we're talking about a pH of 2 versus a pH of 10, pH of 2 has a much, much greater hydrogen ion concentration than a pH of 10. Just to outline some pHs in the body, oftentimes we hear the body pH is 7.4 with a range of 7.38 to 7.42. And that would be accurate if we're talking about the extracellular fluid and the blood plasma, but different regions of the body have different pHs. For example, the pancreatic juices secreted into the duodenum have a very basic alkaline pH, whereas the stomach has a pH which can be as low as 1, which is an extremely acidic solution. So we use the pH scale just because it's much easier. There's a much higher concentration of sodium, as we can see in this slide right here, much higher concentration of sodium than the hydrogen ion. 142 milliequivalents per liter for sodium and 0.00004 milliequivalents per liter of the hydrogen ion. That is to say, the concentration of sodium is 3.5 million times more concentrated than the hydrogen ion. So if we just convert the hydrogen ion to a logarithmic scale, which is exactly what the pH scale is, it offers us numbers that are much easier to deal with. So let's compare some pHs, just so we're all on the same page. A pH of 3 is 10 times more acidic than a pH of 4. Keep in mind, we're talking about a logarithmic scale. So a pH of 3 is not just 1 unit more acidic than a pH of 4. It's 10 times more acidic. Whereas a pH of 3 is 1,000 times more acidic than a pH of 6. And that's really important to understand because we're talking about a logarithmic scale, the differences in pH can be dramatic. So why is pH important? Because pH can wreak havoc on proteins in the body. And as you can see, proteins make up a lot of things in the body: antibodies, receptors, channels, enzymes, signaling molecules. And if something happens to those proteins, if they denature, they're not going to function as they are supposed to function. So just so we're clear, a denaturing is the unfolding of a protein. Proteins are held together by covalent bonds, van der Waals forces, disulfide bonds, and hydrogen bonds. And the significance of pH is that the hydrogen ion can disrupt the hydrogen bonding within protein molecules. So if we denature a protein, which is to unfold it, then that protein's not going to function as it normally does. And if proteins aren't functioning, we are what's scientifically known as SOL. So it's really important to maintain pH in the body. In our next video, we'll talk about mechanisms within the body that help us maintain body pH.